How's it going, everybody? Today I'm going to show you how to microsquirt your J35A4 or your J32A2. I've verified this on both of these swaps. The Del Sol is running the J35A4 and the EF hatch is getting a J32A2. I'm going to kind of jump right in this and see how it goes. The Microsquirt is a small ECU. It's very cheap compared to other standalone ECUs. You can see here the Microsquirt is hovering around 315 bucks, 314. So this one is just the bare bones. This is just the Microsquirt, no harness at all. And you are actually going to want either the 8-foot harness or the 30-inch harness. The 8-foot harness I suggest if you're going to go ahead and run the wires directly to your engine, and the 30-inch one I suggest for people that are going to use the factory harness on the motor and just tie the micro into that at the firewall. A couple other things that you're going to need is a Microsquirt ECU data cable. Most people are going to be on a newer style laptop. It's going to have USB. If you notice from here, the cable that is supplied is actually a serial cable. This only works with older PCs. I actually haven't seen the serial cable on a new PC in a long time. So these cables are fairly cheap. I picked up a spare, so just in case I break one at the racetrack or something like that, then I have a backup. The other things you're going to need is a sealed resistor, a 1K, and you are going to need a 10K sealed resistor. You actually don't have to buy these. You can actually make your own. These resistors are super cheap, and if you have these heat shrink tubings, then you can put around them. But this makes it a lot simpler. I would suggest just buying them. So, why the Microsquirt? Well, one, it's fairly cheap. It's under 400 bucks. You get your wiring harness, and if you have a motor with an existing harness, you can either make pigtails out of all of them, or you can wire this harness directly into those connectors. To do that, you'll need the female and male terminals and a set of crimpers. I've got the crimpers off of Amazon, and the terminals I got off of eBay. They're fairly cheap. It just takes a lot longer versus tying the pigtails to the Microsquirt harness. So with that, let's just get into it and get right into the Microsquirt wiring diagram. And remember to like, share, and subscribe. Let's get into this. All right, so let's go over the map sensor. The map sensor is a 3-wire sensor, and it reads the manifold air pressure. So I ended up running a 4-bar map sensor on my Del Sol. I knew that I was going to be up in the 20-ish PSI by the time I was done, and I just wanted to make sure that I was covered for any future activities that I had with it. But for the wiring, it has a 5-volt V reference line, and it is shared between the map, the throttle position sensor, and the WLED through a 1K resistor. And I will get into that in a little bit. You have the out, which is actually the map sensor signal, and then you have the ground. This is a sensor ground. Stated right here is a sensor ground. And I believe that is pin 20. It is going to be a black and white wire, and it will state on it sensor ground. Basically, any sensor that is going to be a 5-volt powered sensor is going to use a sensor ground. These are not grounded to the engine directly. Alright guys, let's cover the air temp sensor and the coolant temp sensor. These two are the simplest sensors in the whole system. The coolant temp sensor comes from pin 25. and the air temp sensor comes from pin 26. They both share a sensor ground. I did switch over the air temp sensor. The factory J sensor is a manifold air temp sensor, and the one I went to is an intake air temperature sensor. Generally, they are the same thing. It's really just a location. The manifold temp sensor was reading elevated temps after sitting in line at the drag strip. By the time that I would get to the starting line, my manifold air temperature sensor was reading about 150 degrees, which actually started pulling timing. The intake air temperature sensor is placed about 6 inches ahead of the throttle body, and it does not get this heat soak problem. I would highly suggest just going to this, as it will make your tuning a little bit easier, but that is totally up to you. The factory sensor will do on most cars. Let's go over wideband controllers. I use an LC2. This is literally the only wideband I've ever had. I have friends that use AEM and they swear by them, and I've had them use them, and AEM had a bad batch out a few months ago, and they had to have 2 of them replaced. I've had this LC2 for probably 7 years. I've never had an issue out of it, so I am going to stick by them. My LC2 actually has 2 outputs. It has like a narrowband output and a wideband output. I use the wideband output. This sensor or wideband controller is powered by 12 volts. If you follow this red line, you will find that it is ran off of a 15-amp fuse, and then I ground this to the engine. Since it is powered by 12 volts, I ground it to the engine. They do have a sensor ground here. Mine actually does not have that. So, with that being said, I am going to say you will have to figure out how your wideband needs to be wired. Some of them may have a sensor ground, and some of them may just have a power ground. They are all made a little bit differently, so you will have to do your own research on this. Let's talk about the throttle position sensor. So the throttle position sensor is going to have 3 pins. It's going to have a 5-volt reference, a signal, and a sensor ground, just like the map. So it's going to use the 5-volt reference, the VREF, from the Microsquirt, pin 28. It is going to use a TPS wire from the Microsquirt, pin 27. This one is labeled TPS. And then a sensor ground, which is going to be shared with the coolant temp, air temp, and the map sensor. This is a very easy sensor, and in Tuner Studio, you will end up calibrating this sensor from 0 to 100. If you wire this wrong, you will get some weird readings, and it will basically tell you that, hey, something's wrong. Your throttle position sensor will be bouncing all over the place, even though you're not touching anything. So this one's a pretty hard one to mess up, and if you do mess it up, it's going to be apparent. Let's go over the A-LED. Now the A-LED is a spare wire on the Microsquirt that allows you to use a programmable input. And what I mean by this is you can make this wire ground out something under a certain condition. So you can actually make this control fans or a relay, or let's say you have methanol injection or something like that. So in this case, we're going to use the pin 16, the A-LED, and we're going to ground a relay. And the reason for this is because this can only ground. Now, it can only handle very low power. So we are going to run a key on power, and this thing is going to use so minimal amount of electricity that you can literally run it pretty much off of any fuse here. So pin 86 is going to get power. It's going to go through. A LED is going to ground it above 3,500 RPM and above 70% throttle position sensor. We can change these values to whatever we want. The other power is going to go to pin 30. Now, whenever this is activated, it's going to allow the power to go over to pin 87 and power the VTEC solenoid. The next sensor we're going to cover is the fast idle valve. The IAC, as most people call it. This is going to be a 3-wire valve. It's going to have a 12-volt hot, so I'm going to ground it to the engine. Now, I'm just showing this as a good ground engine. This can actually be run as a separate ground. It doesn't have to tee into that wire or nothing. And then the third wire is the actual control wire from the Microsquirt, which is pin 7. This is going to be labeled as fast idle or F idle. It is a dark green wire, not a pink. So the next thing I want to cover is the fuel injectors. So I used 6 1000 cc high impedance injectors. The Microsquirt has 2 injector banks, so it has 2 wires. The injectors actually get their power from a key-on source, and each bank has to have its own fuse. These are going to be 5-amp fuses. You don't want them to be any bigger than 5 amps. The Microsquirt is actually limited to 5 amps, so you can damage it by going more. So put some 5-amp fuses in there, buy some extras, keep them in there. I've never blown them, but you never know. So the Microsquirt will actually ground out the injectors. So it will fire one bank and then turn around and fire the second bank. The bank 1 I actually have running cylinder 1, 2, and 3, and then bank 2 runs 4, 5, and 6. The fuel pump I have ran separate. This is something that I had to change from the original Microsquirt diagram because I am running a Walbro 450. It needs a 30 amp fuse, and I ran it on its own relay. This relay actually gets power from the key on. The pin 85 on the relay is actually grounded at pin 20. So the ECU will actually control when the fuel pump comes on. So let's talk about the VRN, and what this is the crank sensor, and it's a variable reluctant. I am using the 12-tooth gear off of the J35A4. Some of the J32A2s have them. Some of them have a 24-tooth. If you have a 24-tooth J32A2, you can run that sensor. It's going to be a little bit different wired. I stuck with the VR because it's simple. I had a ton of them, and it was just easier to do. The VR sensor, the positive, needs a 10K quarter-watt resistor in line. And you can get these the same place that you get the Microsquirt from. This is what I was talking about earlier. So you are actually going to solder one end of the wire to the Microsquirt side and then the other side to the sensor side. So it's going to be straight in line just like this. You're actually going to have to cut the original wire and then solder that in there or crimp it in. The reason you need a 10K quarter watt resistor is the variable reluctant sensors gain voltage with RPM. So you will get huge voltage spikes as you go up in RPM. And being that Hondas generally will be revved higher than pretty much any other engine, outside of some specific make and models. These things will generate a lot of electricity, and this 10K resistor just limits that. So another thing to point out here is that on the 12-tooth gear on the crank, we are actually going to take a tooth off. We are going to take this tooth right here off. And the reason for that is whenever the top dead center is about right here, that missing tooth is going to be there. And that's about where the sensor placement is. And this is about 90 degrees crank rotation away from top dead center. The reason why we need the 80 to 90 degrees difference is so that the micro has time to do all the calculations it needs to, and then be able to fire the spark plug at the maximum amount of ignition advance that you're going to run. I can see up to 50 degrees of ignition advance, and that's under like a light load, super light load, just cruising. Whenever it's cold, especially, because you will actually get some advance off of the engine being cold. So the next thing we're going to cover is the ignition system. The ignition system has its own 15 amp fuse. Now this is what's actually going to power the coils. Now generally the Microsquirt only has 2 ignition outs. You have ignition out 1 and ignition out 2. We are actually going to convert the WLED to an ignition out 3. And how we're going to do that is we're going to add a 1K quarter watt resistor to the 5 volt VREF line. And that is going to be this one right here. Now, unlike the crank, we are not going to just cut the WLED and put that resistor in there. What this is going to do is it's going to allow 5 volts to get into that line. The ECU is going to ground that wire. And it's actually going, that power is actually going to go to ground. Now it's only going to allow a very small amount. So whenever it wants the coil to fire, it will cut the ground out. It will send 5 volts to the coil, and then it will ground it right back out to basically signal the coil to fire. This is the pinout on a J series coil. You have a key on. This comes from that 15 amp fuse. I do an engine ground, not a sensor ground. This is important. This needs to be an engine ground or a head ground. I actually have mine grounded to the head. The micro ignition, cylinder 1 and 5 go to pin 12. So these two will fire at the same time. This is wasted spark. Pin 11 is going to control cylinders 3 and 4. And pin 17, which is the WLED, is going to fire 2 and 6. All right, so let's talk about the last couple things that we need to cover. So one of the things I want to point out is the 2 grounds. It's 22 and 23. These are engine grounds. These are the grounds that actually the Microsquirt is grounded to. These ones I took to the thermostat housing, which is where the original ECU ground was. And I figured that would be a really good location because if the Microsquirt quit powering on, I would probably check the fuse first and verify that there is power. The second thing is I'm going to check the ground. Since I'm so used to Honda and their grounding on the thermostat housing, I figured that was the perfect place. Another thing we need to cover is the tack out. The tack out is going to put out a 6-cylinder signal. So if you hook it up to your factory cluster in like an EG or an EK, your RPMs are not going to be correct. You're actually going to read 50% more RPMs. How I got around this was I went to Amazon and bought a Dakota Digital. I bought the Bluetooth one thinking that I would be able to calibrate everything through Bluetooth and it would be easier and safer to do. And it is. So the tack goes in and then you end up wiring out. I wish I'd quit zooming. Another thing about the Dakota Digital is that I actually took the speed sensor in, and these three wires, the speed plus, the input, and the speed minus, go directly to the transmission on the lower sensor. It is a 3-pin sensor, and this I can't remember which out it was. I believe it was out 3, but that one actually went to the dash. You can actually switch in between these three, and then whatever one is the closest to your speed, use it, and then you can do a fine adjustment on the Bluetooth app. The last sensor that I want to cover is the flex sensor. This is a completely optional sensor. I put it in because I actually have a tune for gas, and then I switched to E85. The reason that I wanted the flex sensor was because I actually didn't trust my gas station. There's only one of them around me that runs E85, so if I ended up getting a lower ethanol content, then it would throw my tune off a little bit, and I have literally no other gas stations that are close by that I can go get E85 from. So I ended up going to Amazon and I bought this flex fuel sensor. I actually bought the clips that go onto this, and then I ran 6 AN off of that. I actually put this before the factory fuel regulator, and I thought that I would see more variation. So whenever I filled up with the 85 and got a clean, fresh tank of just the 85, no contamination, I noticed that there really wasn't much variation. So you technically wouldn't have to do that. You could actually put this on the return line. It would be good enough that it would work. And this already has the pin out. I actually bought the pigtail from Amazon whenever I did this. And the VCC comes from the 12 volt key on. And then you have an engine ground. And then you have the out, which goes to the Microsquirt, which is pin 6. And this will say flex on the line. I think that about covers all the sensors. If I missed something or if something was a little confusing, don't be afraid to comment. I will get to it and I will answer your questions or modify the video to help. And with that, we are pretty much finished up. I'm going to go ahead and cycle through the pinouts for the various sensors. And you can pause the video if you need to see a specific sensor. And here we go. The air temp sensor, I did not do the pinouts on, but the closest one to the clip is actually the ground. I actually don't think you can get either one of these backwards, and by either one I mean the coolant temp too. They're just 2-pin thermoresistors, so it shouldn't matter which direction they are. This is the sensor that I got, and I welded the bung inside my intake. And there's the open element, and this one actually came with the pigtail. Same as the other two sensors, it actually doesn't matter, but they already had theirs color coded, so the black is ground. And mine actually came with a yellow wire, not even a red wire. Here's the coil pinout again. Again, you have a key on from the 15 amp fuse and the engine ground, and then depending on what cylinder it is will depend on what pin the micro it uses. Here's the fast idle valve, or the IAC. Again, this is a key on, 12 volt. You have an engine ground since it's a 12 volt sensor, and then the micro, pin 7, controls the valve. Here's the map sensor. This uses the 5 volt reference, a sensor ground, which is pin 20, and the signal going to the micro, which is pin 24. And similar to that is the TPS. You have the 5 volt reference, the signal, and the sensor ground. Whenever you go to wire in the crank sensor, you can get it wrong. And if you get it wrong in Tuner Studio, when you go and do a high-speed data log and do a tooth counter, if you have it wired backwards, you will get 2 teeth. And you have to start the tooth logger and you have to crank for about 5 to 10 seconds, and you will start seeing these lines. And these are your missing teeth. Or tooth. It's not even teeth. You don't want to take 2 off, you just want to take 1 off. This is what it should look like. You should have 1 missing tooth, and then all the rest of the teeth are going to be like this. The reason why they're like this is actually the compression strokes of the cylinders. So it won't just be straight across. It'll never be like that. And again, here is that crank gear. Now this is the timing belt gear, and this is the only tooth you want to grind off. And you want to try to keep that as circular as you can. I hope you guys enjoyed this video, and remember to like, share, and subscribe. That way you can get future content. And if you have a moment, check out some of my other videos. And have a great day.